Welcome guys, I'm Chris and this is another special episode of Rift Amps. Right, so this is a home kit amp. It is an Ampmaker kit, the SE-5a model, which is a single-ended 5-watt single-ended amplifier, 2 gain stages, one of which is an anode follower. I'll show you the schematic shortly, but these were very, very popular kit amps here in the UK. Lots of people built them. You buy yourself the kit, you do all, you disassemble it, and then you'd have, either make yourself your own head shell cabinet or combo if you wanted, or you'd have someone else build one for you, which is the case here. Very, very nice indeed. So I can't remember if Ampmaker is still going. The website is definitely still up. I'll look online. I should have checked before I started the video, so apologies if I've got that wrong. But this one has come in for a bit of a check over and a service, do your thing on it, as it were. Make sure it's okay. If there's anything inside that needs fixing or can be done better, we can do that. Customer has authorised 2 hours work on it, so that's what I'm going to spend on it. We're going to try and improve this thing as much as we can. Now, being that it's a home build kit amp, we don't know at this moment in time whether or what the build standard is like inside, so we're going to find that out. But with these, I always assume the worst and then I'm never surprised, right? Okay, so here's the schematic anyway. The SE-5a, and it's we'll start with the power supply. So we've got 240 volt input. We've got our 6-volt winding here, feeding both V1 and V2. Now V1 is probably a 12AX7, I would have thought, and V2 is an EL84. And just like we saw on the Mad Amp, the heater winding is not center tapped. It's got an artificial center tap, 2 100 ohm resistors either side, and they're tied to the cathode of the EL84, so the heaters are elevated to help reduce some noise. The high voltage supply, a 190/190 center tapped winding, full wave rectified, standby switch, got a 47 microfarad reservoir cap there, 100 ohm dropper there, and then here's the interesting thing, the second cap in the chain, also a 47 microfarad, feeds the output transformer. Okay, you notice it's a single-ended output transformer, so there's no center tap, straight through the winding to the anode or plate of the EL84. The screens are fed from point B, so we've got a 1K dropper to a 22 microfarad cap. B, that feeds our dropper. And look, his screen resistor there is a 2K2. Much higher than the 100 ohms you tend to see, which is very low anyway. The preamp is fed from point C, but you'll notice that's not downstream of point B, it's connected to point A. You see how that jumper is there, and we've got a bleed resistor to ground to drain the whole system down when you switch the amp off. Very cool. Preamp section, single input, just a 1 meg resistor on the input there. No grid stopper. That's interesting. No grid stopper there. In my opinion, we should have something there. For a single input, the calculation is usually, what is it, 34K or 33K, something like that. But you can do tricks. You could do like a 10K, and then you can have a small picofarad cap to ground. That helps reduce Johnson noise. Got a 1K5 cathode resistor, pretty standard, although it's bypassed only with a 1 microfarad 25 volt cap, not a 25 microfarad cap. So we're not boosting the full range of frequencies there. So we're looking more in the modern, Marshall stroke modern style there, 100K anode resistor. 22 nanofarad coupling cap, a 1 meg dropper into the 1 meg volume pot or gain pot, I guess we call it in this case. Yeah, because we've got a master there. Gain control there, feeding the second half of V1. This time biased much hotter, 820 ohm resistor. Again with the same value coupling cap and the same value, sorry, bypass cap and the same value plate resistor, anode resistor. That's driving the tone stack, so coming off the anode, so it's an anode follower. Treble middle and bass, sorry, treble bass middle, yeah, middle's always at the bottom. 500 picofarad, 2222. That's very martially indeed. And we've got a 1 meg master feeding our output valve with a 5K6 dropper. Very interesting, very simple, not much going on. But also, where you've got a very simple amplifier with very little gain stages, you've got a lot of scope to make changes. You know, each component has a bigger effect on the overall sound because there's less of it going on, so each component carries more weight. It's a good way to put it. So here's the amplifier. Got an on-off switch, dual light in the middle, on standby switch next to it. Got a master, treble middle bass, the gain control, and the single input. Now I can't remember, because he also did an 18 watt, what they call the 18 watt light version, which was just with the volume and tone, and he also did a treble middle bass version. So I think that this is a stripped down version of that, rather than that, the 18 watt being a beefed up version of this. I think that makes sense. So that's what we've got on the front. We spin it round, God, it doesn't weigh much at all. Got 2 speaker outs on the back, 8 ohm and 16 ohm. Got our mains fuse there, and we've got an IEC socket on the back, which I like to see. So let's get this thing apart, have a look inside, then we'll get it on the bench and take some basic baseline measurements. Okay, what do we see then? So we've got V1 all the way over here. That's quite a gap. That's quite a distance. I mean, that's an 8-inch spacing there. That's quite a long way away. So what have we got in V1? Probably a JJ, I would have thought. Yeah, JJ ECC 83. Ceramic valve bases. And the output valve, also a JJ in EL84. Right. Get more light in there. There we go. So we've got a output transformer, UK made. I think these were made by Danbury. Yes, they were. And we've got a very, very tiny mains transformer. And that stacking is just over 1 inch tall. Very cool indeed. Right, let's pull the chassis out. And then we can look inside. Okay, let's get a better look at this output transformer. So it's a single-ended output transformer, as we know, with 4, 8 and 16 ohm taps. Look, it's got a nice protective cover on. So those terminals, even though these terminals are heat shielded, these ones are still exposed. So that's a very nice idea. I like that. 5K primary. Okay, I would have thought it's probably a universal type, isn't it? If it's 5K, you could run quite a few different valves at 5K, depending on your HD voltage, actually. And here's the main transformer. As I said, it is quite small. But that's about it on the top. So I'll just get the chassis stand, and then we can get this mounted. Well, here we go then. So, classic design. So you've got a centralised board with most of your components on, pots along the front, on-off switches and things like that. Power transformer off to the left. All pretty standard, really. So I can't remember if my customer has built this or if someone else built this and he's bought it. I can't quite remember. So I'll be gentle. But I'm just having a look around. We can definitely improve the mains switching here. You know, we can tidy up. Sorry, the wiring. Sort that out. Make sure all these solder joints and things are good. Make sure the fusing is correct, and we've correctly sleeved the terminals. Got lots of things floating in the air, so we'll stick it on the bench and see if there's any strange artifacts and things going on. But apart from that, not bad. It's a kit amp. Not bad at all. Obviously, if this was a professional build and someone was charging for this, we'd be having different things to say, but not the case here. So I'm just having a look. None of the pots have got lock washers. The standby switch moves. That's not tight. The power switch moves as well, you see. A lot of play there. And it's basic stuff like that we need to get right. None of the transformer doesn't have locking hardware. None of the sockets have locking hardware, as I can tell. There might be a lock washer underneath. I need to look closer. So things like that, that we can improve. I can't tell if on the... Oh yes, there is. On the safety earth bond, there is a lock washer. So that's not going anywhere. Not bad. Okay, not bad at all for a kit build. Let's get it on the bench, fire it up. Okay, running on the bench at idle, it pulls just 22 watts out of the wall in restriction mode, and we'll give it full power. 24 watts, so not much, right? Okay, I'll show you the sine wave. Asymmetrical, it's single-ended, of course. Keep bringing it up. Just starting to clip there on the lower half. 4.88 volts, call it 5 volts. Puts us at 3.1 watts. So it is a little bit down. What do we need for 5 watts? We need just somewhere between 6 and 6.5 volts. So that now is doing 5 watts. Not sure about that. Not sure about that. Okay, bring that back down. We'll leave that running. I've taken some measurements, and this is what we've got. Also, big shout out to Stuart, who has given me a couple of calculators. Sees me struggling with the iPad. She's got me the KK800A model. Absolutely beautiful. Works great. Big fan of this. Thank you. But here's the measurements. Anode to cathode voltage, 218 volts, quite low. The screen voltage is 4 volts higher, which is an absolute no-no. We've got to sort that out quite quickly. Voltage drop across the cathode resistor, 6.35 volts, and the cathode resistor itself is 150 ohms, spot on, bang in the middle. Gives us a cathode current, 42 milliamps, 0.042 amps. Puts that EL84 running at 9.23 watts. 12 watts is the maximum, so it's currently biased at 77%. That probably is a good starting point as to why we're slightly down on power. We could probably squeeze much more out of this, but that's where we are. That's where we are. So I'm going to... What's my plan of attack? Well, I want to sort out the mains wiring. I think I mean, there's no ultrasonic oscillations on this, so I mean there is shielded wiring to the grids, from the input to V1A, and there is from the master volume into the output valve. Okay, so we haven't got any stray coupling going on, but there's always some improvements to make. You know, I've got 2 hours to spend on this, so I'm gonna go through. So here's what I think we should do. Right, I want to put lock washers in all the pots, so they don't rotate unwantedly. I want to tidy up the mains wiring. I want to see if I can improve some of the signal wiring going through, and I want to check and adjust the bias. Right. Apart from that, not much. Oh, and I want to sort the main switches out and things like that. Stop those rotating. See if we can come up with a plan for those, because it's not good. But apart from that, I don't really see much too wrong with this as far as home-built kit amps go. So it's certainly putting out somewhere near the power it should do. It's got good tone. It just needs a tiny bit of fettling. Always really important, if you're in this industry and you're doing this type of work, is to put your hand up when you make a mistake. So these measurements that I took here was when the amp was in restriction mode with the light bulb in place. Reason being I didn't spot that was because the current draw of the amp was so low that the bulb wasn't glowing anyway. So back in full power mode, these are the numbers. Slight improvement. 230 on the anode, 234 on the screen, so that's still an issue. Our bias current now, or operating current, is now 44 milliamps rather than 42, puts it just over 10 watts. We're down at 84%, so we're still low, but not as low as we were before. So glad I caught that. And now I've got my correct baseline. So we could say restrict, and we can say full. And now I know. Now I've got 2 sets of data. Phew! Right, let's crack on. Actually, I've just seen the fuse holder is wired backwards. You want the live coming from the IEC socket to the back of the fuse holder, and then from the side connection off up to your switch. So glad we're doing this. Right, so that's the main side of the input wiring done. All properly, all nice and done, nice and neat. Next thing I want to do is the shielded wire coming from the master volume pot to the input grid of the output valve. I don't want it passing underneath the heaters. I want it to go over. Mainly because even though it's shielded, it's still getting close to these wires. So all I've got to do is unsolder it, route it over the top and solder it back into place. But all these solder joints here are not great. So I'll just undo it. I might get a new resistor and put that in place because this one isn't great either. What value was it? 5K6? Right, a couple of considerations then. So first thing, we know that our bias is slightly cool and we could do with upping it slightly. So we do that by reducing the value of this resistor here. This is the bias resistor. It's a cathode biased output stage, right? 150 ohms. Well, E12 values tell us the next one down is 120 and the one below that is 100 ohms. So we will, as we're 2 watts off, let's sneak up on it with 120 ohms. We'll do that first. And the other thing, of course, remember our screen voltage coming into pin 9 is a couple of volts higher, which is an absolute no-no. We need to get that below the anode voltage. I think we were 230 here, and here we were 234. So really we need to drop 5 volts. The screen resistor is a 2K2 on this schematic. However, I'm struggling to find it in the amp. So it's this red wire here, which comes from up here somewhere. I think they've got a 1K in this place here. It should be a 2K. If I buzz it out quickly and we find that that's the feed to the output valve, then we know that that 1K is the resistor we need to swap out. Pin 9. Yep, that's the one. So this 1K that they've got installed in the amp needs to go to, well, they've said a 2K2. We could use Ohm's law to calculate where we need to be. Yeah, let's start with a 2K2. Because I didn't measure the screen current. So we can't use Ohm's law yet. So let's do 120 ohms here and actually put the 2K2 in where they've got a 1K there. Let's start with that. And then we can fire it up on the bench and take some more measurements. Right, back on the bench. It's fully warmed up. It's had about 20 minutes now. At idle, no signal. It's now drawing 26.5 watts out the wall. That's the output sine wave. It now stays cleaner for longer. Although, being a single-ended amp, you do get an asymmetrical sine wave. And when I say longer, it's not huge, but it is better. Right, let's look at the numbers. So these are the new numbers for the operating conditions now. First thing, our anode to cathode voltage has remained the same, but now our screen voltage, crucially, is now a couple of volts lower. So we're back into the healthy range. Happy with that. Our cathode voltage, so cathode to ground, across the cathode resistor, 5.96 volts down from 6.63. And the value of that resistor is 119.3. So current, we want cathode current, is voltage divided by resistance. So 5.96 divided by 119.3, 49.9 milliamps, 0.0499. Power is voltage times current, so we need to do our anode to cathode voltage, 230 times by that number there, times by 230. We're now at 11.49 watts. Maximum is 12, divide by 12, 95.7%. 95.7%. Excellent. And it's running quite nicely. It's running quite nicely indeed. Could I do more on this amp? Yes, of course. You know, with time and money, you can make further improvements. But now we've just, well, first of all, we sorted out the main side of the wiring, make sure that's safe and good and proper. And we've just made the slight tweaks required to get this amp more into that happy zone where it's happy, it's performing well, it's well within spec, all the controls and things are working great. I'm happy with all of those, and I've got no complaints. So I think we will, as this is a Bonfire Night special, let's do some sound samples, get some playing going through this, see what it sounds like. I'm going to run it through my 2x12. I think it's got an Eminence Red Fang and a Celestion V-type in there. So we'll mic up one of them. And you lot can have a good listen. And let me know what you think. Okay, so back in the head cab, all set up. I'm going to run some loops through it. And I've got the bench cab mic'd up too. So I've already had a bit of a play around with it. Bass kind of on 3, mid on 4, treble on about 3 as well. Seems to be where it's happy. I'm going to turn the master up full and then bring the gain up slowly in stages all the way so you can hear the difference. And then we'll start messing around with the EQ. So standard Ainsley loop we'll start with, number 10, the one you will know and love, and then we'll take it from there. But that's already running. So master on full. Okay, well, we'll call that one done. If it was my amp and I was going to mod this further, what would I do? Let's get the old schematic, shall we? Let's get the old schematic up. So we've got pretty standard front end for a Marshall-y style amp, a British voiced amp, you might call it. I would double check the heater capacity, the current capacity, the amp's capacity for the heater winding, because if I can have another trial in there, add another valve, you get a nice increase in gain out of it, but also you wouldn't suffer on headroom too much. And I know it's a very simple amp, and that's kind of the whole point of this thing. But if it were mine, I would probably add an extra gain stage in there just to boost the signal a little bit more, so we can drive that output valve harder and recover from the tone stack a bit easier. I think that's what I would do. Apart from that, filtering's good. No negative feedback, so it might be nice to add some negative feedback. Maybe a presence control would be nice as well, although there isn't room on the front panel, so you kind of have to decide what you want to do there. But apart from that, yeah. If in that size chassis you can do a lot. It's an 18 watt or a 45 JTM 45 style chassis, so there's a lot of room in there for messing around. So you could do quite a few things actually. But yeah, very interesting. Enjoyed that. Not much to do really. Just as just a little, just basic service stuff really. Just tweak it and get the amp running more optimally, getting it where it needs to go. I'm not overly fan of the top end on the amp, but it's not awful, and you can dial it out with the treble control, so that's not too bad. You might, no, that's all right actually. That's fine. I would. Do you know what you could do? You could wire in or add a 6v6 socket again if there's the heater capacity. Have them both running, and then you could have a pot. So you go into the wiper. One side of the pot feeds the EL84, and the other side feeds the 6v6. And then you can have one or the other, or anywhere in between. You might have to think about output impedances, but there's all sorts of cool things you can do on these. So yeah, I'm sure there's forums dedicated to it. But yeah, really enjoyed that. That was a bit of fun, wasn't it? Well, that's it then, guys. Thank you very much for watching. As you've heard, I've managed to turn the gain down on the old fuzz box now. So a couple of days' time, I reckon I'll be back to full twin reverb mode. But yeah, so please give this video a thumbs up. All your comments and questions down below. Subscribe if you haven't already. Why not join the channel? And I will catch you all at the next one.